eclipse glasses on the entire time. You can also use other indirect viewing methods too, like a pinhole projector if you don't have eclipse glasses. So Michael, do you have your glasses ready?
I have mine ready.
Great. So now let's go to a full screen view of the telescope here in Albuquerque. Wow.
Wow.
We are minutes away and you can see that the ring of fire is almost here.
Yeah, the sun is just egressing over into the moon, or the moon's egressing onto the sun. We're getting closer and closer. The light here on the ground is visibly different, and looking up at the sky, where we see a thumbnail moon. It is our thumbnail sun. It is gorgeous.
Wow. The ring of fire, the almost ring of fire, it looks so sharp and clear with our beautiful skies today.
Yeah, it really is almost that Johnny Cash moment. We're getting close to the ring of fire. It is really beautiful to see happening in real time as well. This is one of those events where I can sit and watch and see how the moon is progressing and see that changing.
I can't believe that the moon, we can actually see the moon moving in front of the sun right now. You can literally see it. It's just incredible.
So as we approach annularity, you might be able to see Bailey's beads. These are bright points of light of the sunlight coming through the valleys on the moon itself, right before the annularity begins.
You can even hear the crowds in the background. You can just feel the atmosphere building up.
Yeah, it is palpable. Everybody is super excited here. I know I am just thrilled. We are just in the final countdown. You can hear some people starting to cheer and starting to get all pumped up themselves.
Wow, the ring of fire is almost here. I'm just going to take my glasses off briefly and you can see the crowd. Everyone is just staring safely at the sun right now. It's just amazing that we're all united looking at this amazing celestial event.
And make sure you take a look at the shadows around you. You're going to see these crescent shadows everywhere as different objects create natural pinhole projectors. And so make sure that you do have a moment to take a look at the world around you, because there's a beautiful rings. So let's take a minute and just be quiet and enjoy the view. It is a gorgeous sight to behold.
Everyone is cheering. This is so amazing. Wow.
Yeah.
This is amazing. You can hear people screaming in the background.
People are so excited. And take off your eclipse glasses safely, of course, and make sure you look at the shadows around you, look at how the environment has changed, just make note of this entire event.
Wow, this is so amazing. This really puts our planet in perspective with the whole solar system, you know?
It's truly spectacular. It's one of those natural phenomenon that I just feel so lucky to be here at this place at this time to be able to observe it.
Wow, I'm just looking at a tiny pinhole below and I see a little ring, like a little spotlight. This is so cool.
You can see ringlets dotting everywhere around here. See people taking pictures of the ground.
How are you feeling, Michael?
Oh, this is spectacular. You know, we've been preparing for this event for so long to actually be in this moment and to be experiencing it live is just tremendous. Joy, how are you feeling?
I'm just in awe. You know, I can feel the temperature drop, and this ring of fire feels so long.
Yeah.
It's just about 4 minutes long, and it feels just incredible that we are seeing moon right in front of the sun right now.
So that moon's shadow is traversing across the ground at a few thousand miles an hour, almost Mach 3. So even though it seems like it's lingering, it's actually making really good progress. And pretty soon our colleagues in Kerrville will be seeing annularity too.
Wow, and the crowd, everyone is still staring, looking at the annular eclipse. I love that everyone is here together, enjoying this together. Wow.
Yeah, you can almost hear a little bit of an awe and reverence among the crowd. Like initially there was a bit of cheering, and then everything got a little bit quieter as people took in the sight. I think that, as people experience this event, it strikes both, personal but also communal, and it's a really beautiful, beautiful event to see.
I would say we have about thousands of people in the fiesta today and hundreds on the museum grounds. Everyone is just excited about this eclipse, and it's just so lovely to see.
I think also what I really love to do is to look at the crowd and see everybody looking up at the sky with their glasses on in the same place. It's fun to do a little bit of people watching as well.
Yes. Wow, this is a perfect ring of fire. It's just so crisp.
Yeah, it's fantastic. I'm so excited for the science that is going to be coming out of this too. Of course, I always come back to the science, and this opportunity to have the moon covered to this extent is going to provide us really amazing data about how the sun and moon and Earth how they interact with each other.
Oh my goodness, we have about 30 seconds left of annularity here. I just want to absorb this moment.
It's so fast and so slow.
Definitely. Wow, what a sight.
Sometimes you just have to take a moment to take it in.
Yes. Oh my goodness. Well, we have a few more seconds left of annularity in Albuquerque.
Yeah, we're closing down on the last little bit. See if you can see a Bailey's bead possibly popping up right as that edge of the moon it aligns with the edge of the sun. Just seconds left. Really such a gorgeous sight.
It really is. Oh, that is going to be a moment to remember.
Absolutely.
So Kerrville is going to be experiencing this very, very soon. So let's head back to them in Kerrville, Texas to see what they're up to.
Oh, I mean, Joy and Michael, I got goosebumps watching you experience annularity, and Gina, that is about to be us soon.
It's true. I mean, so Tahira, we're about 550 miles away from them, and we will have annularity in about 10 minutes because, as Michael said, the moon's shadow is traveling more than 1,000 miles an hour. Everyone's so excited.
Yeah, as you can see, the crowd is just getting excited for today's opportunity, and folks, it's starting to get dimmer here. It is going to be amazing.
Yeah.
So, Gina, other than sheer beauty, why do we observe eclipses at NASA?
Well, NASA can learn a ton of different science from the eclipses. So let's talk about exoplanets for a second, because when we study exoplanets, we are actually using eclipses. The planet itself is passing in front of its host star, and so we can learn about the exoplanets. There are eclipses on other planets in our solar system that we can study, but here on Earth, the science that we're able to do will inform us about the upper atmosphere and how it responds to the sun. So really understanding kind of that sun-Earth connection. We can do lunar science as well, and of course, solar science, learning more about the sun.
So eclipses are touching Earth science, planetary science, sun science.
Everything.
It's incredible, and NASA's studying it all.
Yes, exactly. We take advantage of that, for sure.
Absolutely. I mean, spectacular sight, spectacular science.
Yeah.
So, folks, we have James standing by at our Eclipse desk with a telescope operator who's going to show us the next city experiencing annularity. James, how are things looking?
Yeah, hey Tahir, I just had a quick look outside. It is really surreal here. It's kind of hard to process exactly what we're seeing because it's daytime, but it feels like it's not. It's starting to get already very close to annularity. You can hear a lot of screams behind me now. Right now, we're actually getting the annularity in Roswell, New Mexico. They should have a phenomenal view outside right now. And I'm actually joined by a telescope operator who's been providing a phenomenal view for us all morning with her telescope. This is Kat Troche. Thank you so much for joining us today.
Thank you so much for having me. This is so exciting.
Yeah, it's really mind-blowing seeing it. And so you have quite the setup. Could you walk us through exactly what you have outside for us?
Sure. I have a Celestron 6 SE. It's a Schmidt-Cassegrain telescope with a solar filter on the front and a DSLR camera that's streaming to YouTube.
And so a Schmidt-Cassegrain telescope is a bit of a unique telescope. Usually you think of kind of like a long cylindrical thing, but this concentrates the image in a different way, right?
Right. So it's a little bit more compact. It's definitely designed for astrophotography in mind. And how it works is there is a glass corrector plate in the front. It's clear glass. And the light from anything that you're looking at, whether it's planets or in this case today the sun, will travel through the corrector plate to the primary mirror that's at the back of the telescope. Then that will bounce back into the secondary mirror that is attached to the corrector plate on the front, and then it'll go through again back into the diagonal that's attached to the DSLR camera or an eyepiece if you're looking at it.
So a pretty complex process, and also you have to have special protection for the telescope itself because you're used to looking at pretty dim objects. What do you have set up for that?
So I have a white light solar filter, and it is incredibly important. Just like protecting your eyes, you need to have solar equipment for your telescope or your camera if you're photographing the sun.
Yeah, and so also this is obviously moving really quickly across our sky. You just heard from Michael that this is really quite a quick event here. So how do you keep it in the field of view of the camera?
Well, thankfully, the remote control that's part of the telescope actually has a city database set up, so I can program it for city and state, and Kerrville was actually listed.
Look at that. Very awesome. And yes, so you can see it's already moving very quickly towards us. This is where annularity is going to be currently taking place. You can see we're next in line here, coming up in just a little bit. So very excited to continue tracking this across our skies. Thank you so much for providing this awesome view for us all morning. You can really see it's really getting close now. It's got this beautiful crescent to it. Usually we're used to a crescent moon. We've got a crescent sun today. I mean, really awesome. And in just a few moments, we're going to have the ring of fire of annularity. Very excited to have that. Thank you so much for joining us, Kat.
Thank you.
And back to you, Tahira.
Thanks, James and Kat. Now, we have about 6-ish minutes, 6:30, until annularity makes its way here to Kerrville, Texas. As you can hear, the anticipation is high.
They're so excited.
And so, Gina, as we count down to the big moment, let's take a few social questions.
Let's do it.
Okay, so we have something to see here on X who asks, am I seeing a couple of sunspots on the telescope feed?
Yes, so you are seeing some sunspots. As I look at the live feed, maybe not so much right now because the moon is blocking most of the sun, but when the moon wasn't covering as much of the sun, you could see some darker spots, some black spots here and there, and those in fact are sunspots, which are areas of really intense magnetic fields, and the surface of the sun is actually cooler, which is why they appear darker than the rest of the bright sun that we see. Now, we heard a little bit about space weather and some of that solar activity that's coming towards Earth during, some of the sun's activity, and basically these sunspots are where that activity can come from. And right now, the sun is in the part of its solar cycle where more of those sunspots start to appear. So the sun goes through an 11-year cycle, where it becomes active and then where it becomes less active. And right now we're inching towards what we call that solar maximum. And so more and more of those sunspots appear, and that's what we're seeing today.
That is incredible. And I mean, again, talk about activity. Gina, this crowd right now, like folks, if you could see it, I don't know if you exactly.
There you go.
We have folks looking up already with the Eclipse glasses on. You see the live telescope feed in your on the screen right now. We are moments away. What I think is super cool, we've even got some folks out here with their own telescopes and cameras to really capture this spectacular event.
Yeah.
And so again, it looks like we've got about 4 minutes. The crowd is growing, and I'm interested to see how everything kind of calms down too.
Yeah.
So we'll see. Gina, I have another question. This is from Baron on YouTube, who asks, does a solar eclipse have a material impact on the atmosphere?
Oh, I love this question because with the eclipse, we really are trying to understand the Sun-Earth connection. And so you can almost think of the eclipse as a controlled experiment. Basically, the fact that we often, experience changes in our atmosphere during the nighttime, but the eclipse is almost able to turn off and on the sun. So
even right now, we were blasted with the sun earlier, and now it's just chilly. Like it's darker.
Yeah, and so it's the upper atmosphere that we're really interested in understanding, and the energy and the radiation from the sun creates what we call the ionosphere, this upper part of the atmosphere that's filled with charged particles. And so when the sun's radiation is not hitting the atmosphere, that ionosphere, it changes in its density, its temperature, and we're really trying to understand those changes, and the eclipse gives us that opportunity to really turn the sun on and off, which we can't do
in
any
little
other
experiment
circumstance.
That honestly all of us also get to be a part of.
Right?
So that's really cool.
It is.
Thanks, Gina. So our next question is from Hunter on YouTube, who asks, does the solar eclipse affect the moon when it happens at night?
Okay, great question, Hunter. So today, as we're experiencing a solar eclipse, that means that the moon is between the sun and the earth. Now, the lunar eclipse that can take place is when the moon is actually on the other side of the earth. And so today we're experiencing that solar eclipse, and we see that the moon is very dark.
And it looks like too, we're getting a live feed.
Looking at that feed.
All of another annularity taking place right now. Odessa, Texas. Wow.
Oh, there we go.
It's cool to see this comparison right now. What is that? What's on the side of the screen?
Like we might have some solar activity.
Is that a Bailey's bead?
Yep.
Or solar activity? Wow.
Wow. That's
incredible.
A great view.
It is leaving Odessa right now and heading
It's coming our way.
Us,
you
Gina.
can see
oh my goodness.
In the other live feed that we just have that teeny tiny sliver of the sun left peeking out.
Wow. We've got about 2 minutes here, folks. As you can hear, the crowd is chanting and counting down until our moment right now. Oh, that is beautiful.
It's coming in so quickly too.
And you can.
And I'm going to grab those glasses so that I have them.
Okay, wow. So before we hit our moment and peak in annularity, folks, it's a good time to give a reminder that it is never safe to look directly at the eclipse without proper eye protection when watching even a partial or annular solar eclipse directly with your eyes. You must look through safe solar viewing glasses or a handheld viewer at all times. Do not look at the sun through a camera lens, telescope, binoculars, or any other optical device while wearing eclipse glasses. Wait, 1 more minute, folks. If you don't have eclipse glasses, you can use an indirect viewing method like a pinhole projector, which has a small opening and will project the image of the sun onto a nearby surface. You just heard it. We are under a minute away from the annular eclipse making its way across our area into Kerrville, Texas.
It feels like it's gotten here so quickly. We've been counting down.
I know.
And now we're less than
It is beautiful. And so, again, you're witnessing firsthand the moon passing between our star and the Earth. And we're taking this full screen right now. Gina, let's take this opportunity and get a closer look.
All right.
Oh my gosh,
and looking around, I mean, everything is so dim.
Oh,
Oh, wow.
oh my God. Wow, you know, like, why am I emotional right now?
Oh, there we go.
Oh my God, this is.
I mean, it doesn't look real.
I didn't think I would cry. Like, what the heck is going on? Wow. This is.
Wow. It looks great.
I mean,
you can just see, it looks like a perfect circle of the sun peeking out. It really is that ring of fire that we have here.
wow. Gina, I thought I'd have goosebumps, but I'm like literally shaking. This is crazy.
I know. I agree.
So, I mean, this
And
is
I'm
your
just-
first annular eclipse. I mean, was it what you expected?
It is to hear. I mean, we've seen all of the photos from previous annular eclipses, but just as I look again, I mean, it's incredible how the moon and the sun are able to line up like this.
And again, I mean, the moon is way smaller than the sun, but right now it's really giving it a run for its money.
It is, yeah.
Why is that?
Well, so a little fun fact about our moon that's pretty incredible. It's 400 times smaller than the sun, but it's also 400 times closer to the Earth.
No
and
way,
that
400 and
400 is the
400?
magic number here, yeah. The fact that 400 and 400, that means in the sky, the moon and the sun appear to be the same size. And that is unique to us on Earth. No other planet in our solar system has that ratio that makes it so special.
So you're saying that if we viewed an eclipse on another planet, it wouldn't look like this?
It wouldn't. I mean, I'm sure it would be great to see, but it would not look as spectacular as this.
Wow, okay, I'm gonna turn behind me really fast.
Yeah, looking around. And you can just see everything. The shadows are a little bit different.
Dark.
It's dim. You get this hazy feeling, but the sky is still blue. That's what's strange about it.
Oh, it's so sweet. We've got parents like holding little eclipse glasses on their kids to look up. This is just, it's really amazing how just like, I don't know, a natural phenomenon can really make the world pause for a second. You know?
Great.
Wow.
You heard the cheering, and now it's
I know,
quiet
now
again
it's
as people are
quiet.
just looking.
And so for us, this is gonna last about 4 minutes until it crosses, right?
That's right.
And why is that? Is that the same in every city or?
Yeah, so there's actually the length of the maximum eclipse can change based on several factors. I mean, each eclipse is unique, and so one thing has to do with where in the moon's orbit the moon is, because the moon's orbit isn't circular, so it will go faster and slower at different parts, and that will make the shadow travel at different speeds. Also, where the shadow is landing on Earth will have an impact, because if you're at the equator, you're going to be rotating much faster than if you were at the poles, and so for that fact, it changes the length of that maximum eclipse too. And that's true not just for annular eclipses, but for the partial eclipses, for the totality, for total solar eclipses as well. And I imagine, you know, our folks at home getting some of those partial eclipses are also having a great experience too.
Wow. I don't know what I expected, but it wasn't this. Like, this is incredible. And so, Gina, I'm sure, I mean, you're in heliophysics, sun science. I'm sure some of your teams are studying today's eclipse. Like,
Oh yeah,
what?
absolutely.
So,
I
what
mean,
kind of science can only happen right now? You know?
Right, we've heard about the sounding rockets that are experimenting.
Oh,
you know,
that's right. We
today,
saw one. Yeah.
studying the upper atmosphere, and so we're really interested in knowing, like right now in our location, as that radiation from the sun's being blocked, how does the upper atmosphere change? And so, in addition to that, I mean, we really want to understand how those sunspots, what's going on when they're covered versus when they are not covered. We can tell the difference in that radiation that's coming from the sun. And so there's so much science that we can do.
And this is just, folks, view is just so incredible. Before we fully pass through this transit, let's check in with James at our Eclipse desk. James, I know you are seeing this. What do you think?
It's truly a surreal moment. It feels like almost nighttime. It's been really breezy, chilly.
That was so
the shadows
awesome.
are all like little rings as well. It's just a beautiful sight. Kind of hard to put into words the exact feeling. I mean, we've been preparing for this for a while. We've, been tracking this all morning with our Eclipse Explorer, but actually to see it in person and to take it in, it's a really incredible moment, and this only lasted about 4 minutes. You can see on our Eclipse Explorer, this is already passing off of Kerrville, heading further southeast to parts of the Texas coast on the Gulf. And the morning is far from over here. For a lot of folks in Central America and South America, their morning is just starting off here. The partial eclipse is affecting still a large part of the region. You can see this whole area that's highlighted here in the larger ellipse here. That's all being affected still by that partial eclipse. And you can see on our track that this is going to continue moving further southeast all the way into parts of South America before the morning's over. It's been just incredible tracking this. And actually, Kerrville, we're in the path of the total solar eclipse for next year. So if I turn on the path for next year, you can see X marks the spot here in Kerrville. We're going to be coming right back here to witness this incredible cosmic event once again, getting that incredible view. Just really, again, very hard to put into words just how amazing this is. Just a stunning experience, and it's been an honor to be here with you this morning, tracking this event as it's moved across. We started the morning in Eugene, Oregon. Now it has arrived and already passed us in Kerrville. I'll continue to track it for a little bit longer here, but for now, back to you, Tahira.
Thank you, James. And folks, this is just the beginning. Today's event kickstarts NASA's Heliophysics Big Year, which is a year where we're encouraging people to do as many sun-related activities as possible in the lead up to next year's total solar eclipse. Now, Joy and Michael in Albuquerque are going to share some of the ways you can play a part. Joy, what can we look forward to?
Now that the annular eclipse is here, the fun has just begun. So today is the official launch of NASA's Heliophysics Big Year. This is a year-long celebration of solar science, and it's modeled after the Big Year concept from citizen scientists in the bird-watching community. So they're challenged to see as many birds as they can, but in the Heliophysics Big Year, we're challenging you to do as many sun science-related activities as possible. And so one way to participate is through NASA's citizen science projects. Here are a few sun-related ones you could join.
Did you know that you can participate in solar eclipse science with NASA? NASA's citizen science projects are collaborations between scientists and members of the public, no matter your citizenship. Several volunteer science projects are gearing up for the 2024 total solar eclipse that you can join. Total solar eclipses don't just look cool, they provide a rare chance to see the sun's faint outer atmosphere. Using telescopes and cameras that are safe for viewing the sun, volunteer scientists across North America will capture images of the total solar eclipse. Scientists will study these images in detail, tracking how plumes of solar material move through the sun's atmosphere. But be careful, without proper tools and techniques, you can damage your eyes and your camera. Did you know you can listen to an eclipse?
So as you can see in the telescope view, the moon is now moving away from the sun, which is really, really amazing that we're still seeing this partial eclipse.
Absolutely, and I think I can see a sunspot in there too, and I think on one of the earlier shots, I could see a prominence. So we're seeing NASA's sun science happening in real time.
So we're getting some amazing questions online. Shall we ask some more?
Yeah, let's get into it.
Answer some more. Okay, so we have a question from Peter Chang on X, and they ask, can filtered telescopes see flares on the sun during totality?
Oh, that's a really good question. The answer is yes. It depends on what filter, though. So if you use just a white light filter, then you have to have an exceptionally large flare in order to be able to see it. If you use a filter like an H-alpha filter that specifically selects one color of red light, then you're going to be able to see flares a little bit more frequently, even even during totality as the corona adjusts to that flare as it erupts.
Okay, so we have time for one more question. Yuri on X asks, if a solar system had more than one star, would they have more solar eclipses? Would they all look like the same eclipses that we have here on Earth?
Ooh, that is getting a little sci-fi, but that's okay. So if we had more than one sun, you'd have to have a moon to block both suns, or maybe two moons to block both suns. So you'd have to have a very complex geometry to get everything lined up perfectly so you could get solar eclipses with two suns and two moons, and oh, it would get very complicated.
Thank you so much, Michael.
You're welcome.
Okay, so now we're joined with NASA's Heliophysics lead, Denise Hill, who's going to tell us more about how you can participate in the Heliophysics Big Year. Hi, Denise. How are you today?
Great. Did you see that? That was my first annular eclipse, and we got a prominence. I am so stoked. That was the dopest thing ever. Okay, okay. Heliophysics Big Year. So, as you've heard before, the sun touches everything. And the Heliophysics Big Year is a celebration, a global celebration of sun and sun science and what we have going on. But it's also, I think I heard you say it, Michael, it's about the community and being communal and just the unity of hearing everybody cheer the sun touches us all in so many different ways. And so the Heliophysics Big Year is going to help us kind of discover all the ways the sun touches us scientifically, but in other ways as well.
And why is it a big year for the sun?
So you saw what just happened, right? Oh, well, that's nothing. Coming up in April 8th, we have the total solar eclipse, and then Parker Solar Probe's closest approach, which will end out the Heliophysics Big Year, but it's the mission that has literally touched the sun, and it's going to be making its closest approach. And then from there, every single month during the Heliophysics Big Year, and it's a big year because it's more than 12 months, but during that time, we have themes for on different ways people can explore the sun and how it touches them. So we have themes like fashion. We're going to be delving into physical and mental and emotional health. The sun touches us in so many ways besides. And then we have missions. In just a couple weeks, we have our AWE mission that is launching, and it's going to be the first space weather station on ISS. And we are so excited. You have no idea.
Wow, there's so many new NASA events and opportunities coming up. Is there any other like science events that maybe people could get involved with themselves?
Yeah, for sure. So we've talked about citizen science a bunch, and that is one of the ways for sure for people to get involved and to do NASA science with real scientists. And then there's also, like, you are a scientist. Every single one of us is a scientist. And we're going to share ways that you can explore the sun, do your own little scientific investigations yourself. And so, yeah, the science is going to be front and center. There's also going to be some